All right, so we looked at unary universal functions and then binary universal functions. Universal functions or U functions, okay, once again, is a function that will operate on all the numbers in the array. Okay, it's going to iterate over all the numbers. The mathematical functions are kind of unary functions. Okay, so it's going to do a aggregation. So sum will be like summing all the numbers. Mean will be finding the mean of numbers. STD will be finding standard deviation of the numbers. Okay, so that's what mathematical functions do. So these are some of the options for basic statistical methods. So sum is going to give you some of the elements, mean, STD and VAR, standard deviation and variance, okay, and then you have min and max. Okay, these are indices of where, okay, in which coordinate the minimum value is or the maximum value is. Cumulative sum is, you go through the array and do a running sum. Okay, so and cumulative product. Okay, so these are some of the functions that are available. So if you use np dot median, okay, median is not listed here, but it is one of the functions available to us. So if you simply specify the name of the array, then it's going to go through the entire array, whatever the shape may be, 1-dimensional, 2-dimensional, or 15-dimensional. It's going to go through all the numbers, put them all in one basket, and find the median or sum or whatever it is. Okay, so for all the numbers, ARR to D6 is that. So that, and median of all those numbers is what is given here. Okay. Now you can specify a particular direction or axis by which we want the statistical function applied. Okay, all of them. Okay, so now if instead of simply leaving median of ARR to D6, but if you specify axis equal to 0, then it's going to go to axis 0 and it will take each one in each element in that axis and apply the function to each element separately. So here ARR to D6 is this. Okay. So it's going to go to the elements here. Okay, so these are the first dimension. So first dimension is that, and that. Okay, so these are the three, and in these three elements, it will take the first set of numbers and find the median for that. And then the first, so it's going to go through each of the elements in the first dimension or axis 0, index 0. Okay. So it will go like this. So you're going to get 4 numbers here. That's your median for each of the positions in axis 0. And similarly, if you put axis equal to 1, okay, now it is now going to look at the second dimension. Second dimension is inside, so it's going to find the median like that, and like that. So the second dimension are the columns, if you will. I mean, if you think of it as a table or a matrix, the first dimension is the rows. So it's going to go row 1, row 2, row 3, then again row 1, row 2, row 3, row 1, row 2, row 3, and so on and on and on. That's your axis equal to 0. Then column 1, 2, 3, 4, 5, then next column 1, 2, 3, 4, 5 column will be axis equal to 1. Of course, these are not rows and columns. I'm using those terms so that we can visualize this a little bit better. Okay, so you get the median in that way. Okay, so you can apply the function upon the array. Don't specify axis at all. Okay, don't say anything about axis. Then the entire array is used. All the numbers are put together, and the function is applied to all the numbers, irrespective of whether it is in a column or a row or whatever. Okay. Now, optionally, if you specify the axis, then the statistical function will be applied along the axis that you specify. Axis 0 means it's going to go row by row. Okay, and then axis 1 will be column by column. Same here. If you simply say ARR 2D6 dot sum, and you specify, so here I'm using the function in a slightly different way. Notice that. Okay, so here I have np dot median, okay, and then I'm specifying the name of the array. Okay, so here I start with the name of the array and then dot sum. Okay, you can use it either way. Okay. So both ways are allowed. So here, if you see, okay, so if I do np dot sum ARR 2D6, that will work too. So these are two different ways of doing the same thing, and in both ways we're using the u function, okay, universal function, the NumPy universal function. Okay, either you can do np dot sum and then specify the name of the array, or you can specify the name of the array dot the function. And the function knows, and the function looks at what's before me. Oh, this is a NumPy array. So I am a NumPy function, so it will go to NumPy and get the function from NumPy group. And it won't use the base Python sum. It will use the NumPy sum. Okay, so with NumPy sum is a universal function, which means it's going to apply to the whole to the entire array. And of course, you can specify axis. If you don't specify axis, all the numbers are considered as just one group, one big group. So if sum means it will add up all the numbers, and you will get back just one value, because it's the sum of everything. Now, if you specify an axis, so here ARR2D6 dot sum. Okay, so earlier I didn't say anything. It was just left on the right parenthesis, nothing inside. Okay, but now, if I specify axis equal to 0, then it's going to go through axis 0, which is the rows, and you get the sum in this way. Okay, so this is the, okay, sum of that, sum of that, sum of that, and sum of that. Okay, and axis 1. Okay, so here I have mean, right? Mean in axis 1 and mean in axis 0 will be, well, let me add mean of x is 0 will be, you'll get 4 numbers back, because it's going to go through each row, and there are 4 columns, so you get 4 numbers back. Is that okay? And then cumulative sum, so here there is no axis, so just start from the top and find the cumulative sum. Okay, so you'll go, let's see how this is done. ARR to D6. Okay, so it goes this way. Okay, minus 0.32, and then add that, and then add that to the running sum. Okay, so and keep going. Now, if you specify an axis, then it's going to be along that axis. So here axis 0, so that means it's going to go like this. Now, row 1, 2, 3, row 1, 2, 3, row 1, 2, 3, row 1, 2, 3. Okay, and cumulative sum with axis equal to 1 will be, it will go this way. So cumulative sum like that, and then start again here, go this way, and go this way. So you get the cumulative sum in axis 1. Okay? And standard deviation or VAR for variance. Okay, you can use either one. Now here the default is denominator n. Okay, I don't know whether you remember from your statistics class. If you have a bunch of numbers, how do you find the standard deviation? You subtract the mean from each number, square the difference, add them up, and then divide by n minus 1. Remember that? Degrees of freedom, n minus 1. Okay, if it is a sample, then you would divide by n minus 1. But if you have a population where you don't have to compute x bar, then what you get is mu. Then you will have x minus mu squared, add them all up, and you divide by n. That is your population standard deviation formula. There is a difference, population versus sample. Population, the denominator is n. Sample, denominator is n minus 1. So the default here is denominator is n. So that is, you don't subtract anything. Okay. For sample standard deviation and variance, you need to use DD of how many numbers you have to subtract from n. That's what this means. So DD of 1 means n minus 1 will be used in the denominator. So that's why these two are different. This is population. If you simply leave it as STD, okay, so that will be like in Excel. So you have what, STDEV dot P and STDV dot S. I think it's in Excel you have, let's look at STDEV. STD standard deviation, okay, STDEV standard deviation dot S, standard deviation dot P. So dot P will be for the entire population, dot S is for sample. So that's what's going on here. So the default is population, and if you want sample, then you have to specify dd of equal to 1. All right? Okay, let's look at this. Find standard deviation of each column of ARR2 D6. Okay, and we want STD. Okay. Now what should you? We could do this with np.std and use the name of the array inside the parenthesis, or you can do it this way. Either way is good. So ARR2D6.std. So what should we have here within the parenthesis? Okay. So we want sample standard deviation. Okay. So simply STD will give you population standard deviation, right? So we need to specify dd of equal to 1, like over there. Okay. Is there anything else that we have to specify? Of course, if you do that, then you're going to get just one number for the entire array, like what we did before. But we want for each column, so that means you have to go through the rows. Okay, so we need one number for each column. Each column we have to go through the first dimension. Okay, like that. So we have to specify what? We have to specify the axis along which the computation should be done. So that would be axis equal to 0. Exactly. Axis equal to 0 will give you, okay, it will go through the 3 rows for each column and it will give you the standard deviation.